Hi everyone, welcome to my video. Um, so today we'll try to, or rather we'll look at Pythagoras theorem. So we want to understand how this theorem works. How can it help us to find the sides of a right angle triangle? Okay, how can it help us to find the side of a right angle triangle? And how can it help us to find even the angle itself? Okay, so we'll try to understand how this works. Now, Pythagoras theorem has got, or rather, the right triangle has got three sides. We have the hypotenuse, we have the adjacent, and the opposite. Okay, so how do you identify that this is the opposite, this is the adjacent, and this is the hypotenuse? So the hypotenuse basically is the longest distance, okay, or rather the longer distance of the right angle triangle. So this one is visibly visible, such that you can even see, you don't need the microscope, okay, to actually tell that this is the hypotenuse. If you can't tell, basically you've seen this tip where the corner, actually the corner of this symbol for the right angle triangle, where it's pointing, usually that's where the hypotenuse is, okay, if you can't see it visibly. Then we have the opposite. The opposite will always be on the opposite side of the angle, okay, the angle that you're given. The opposite side will actually be on the opposite side of the angle that you're given inside the right angle triangle. Okay, so in this case we're using theta. So if it's opposite this theta here, we know that that is the opposite. Then we have the adjacent. The adjacent is actually the side that is attached to the angle and to the right angle triangle. Okay, so basically the adjacent is the side that is attached to the angle that you are actually dealing with, that is inside the right angle triangle. Okay, so it's very important that given a question that involves a right angle triangle, the first thing that you want to do is to identify the sides, because the sides will help you to find the value. Okay, they will help you to find the value of the side that you're trying to find, or the distance or the length of the side that you want to find. Okay, so let's take, for instance, you are given the adjacent and the opposite in terms of centimeters. Okay, you're given the length of the adjacent, and you're also given the length of the opposite. How do you find the hypotenuse? Okay, this longer side here. So what you do basically, the formula would be using Pythagoras theorem. It's going to be hypotenuse, okay, squared will equal to opposite, okay, squared plus adjacent squared. So this is how you find the value of, or the length of the hypotenuse. It's by squaring the hypotenuse equal to the opposite squared plus the adjacent squared. This is how you find the length of the hypotenuse. Now, that is the first case, okay? That is the first case. The second case would be in a case where you are given the hypotenuse and you're given the opposite. How do you find the adjacent? Okay, how do you find the adjacent? So to find the adjacent, because this is a shorter distance, okay, so what you're going to do, you're going to say adjacent squared will equal to this longer side, which is hypotenuse. So we'll have hyp squared minus the opposite, which is opposite here, squared. Okay, that is the second case that you can have. Okay, so that is the second case that you can have. You can have the first case where you have the missing length being the hypotenuse, and the first, or rather the second part, where you have the adjacent, which doesn't have the length. Okay, maybe given the length as a or x. How do you go about finding the adjacent? Okay, so there are three cases here. Case number 3 is where you're not given the opposite. So you have the hypotenuse, and then you have the adjacent, then the opposite is not given. So how do you go about finding the opposite? So how you find the opposite is basically opposite squared will equal to hypotenuse, okay, squared minus the adjacent squared. So this is basically the formulas that you use when you are solving Pythagoras theorem that involves a right angle triangle. Okay, so you might have a situation where you don't have the hypotenuse, you don't have the adjacent, you don't have the opposite, and so what you do basically is to use this formula that we have here. Okay, now that we understand what this whole thing is about, and we understand Pythagoras theorem. So basically, the most used formula is this one, okay? So you can use this one, the first scenario or the first case, to derive, okay? You can derive all these formulas from this many one. So sometimes they write this as a squared equal to b squared plus c squared, okay? So you can have it that way. A representing the hypotenuse, B representing the opposite, C representing the what? The adjacent. Okay, you can write it that way. That would mean that this side is A. Then we have this side being B. So this will be B. Okay, that will actually represent B. The down part here representing C. So you can have a simplified one like the one we have here on top here. Okay, so if we know these formulas, okay, the Pythagoras rather equation or the Pythagoras formula, we can go ahead and look at some examples. Okay, how do we use these formulas that we have here? Okay, bearing in mind that these two, you can derive them from the main one or this one that we have here. Okay, so let's look at the first example. Okay, so let's look at the first example. So I can wrap this thing off. I can even wrap these ones. Okay, we can remain with this one, the simplified one. Okay, the simplified one. Okay, so given an equation like this one. Okay, so given an equation like this one. Okay, let's say you have a triangle like this. Okay, this kind of a triangle. Okay, then we have this side as maybe if we have this one as 5. So the angle is actually here. So we have 5 there, then here we have 4, and then here we have x. Okay, so 5 centimeters and 4 centimeters. Here we have x centimeters. Okay, so we are trying to find what is this length here. Okay, so we want to use the Pythagoras theorem. Okay, we want to use the Pythagoras theorem. So we need to identify which one is the hypotenuse, which one is the adjacent, and which one is the opposite. Okay, so it's very important that we get to identify those things. Okay, so you can easily tell that this is the hypotenuse and this is the adjacent and this is the opposite. So we're trying to find the opposite. Okay, so now what we need to do, we can write that formula for finding the opposite, or we can use this same one. Okay, so like we said, we can give these ones letters if we want, so that we can use this one easily. So this is A, and this is B, and this is C. Okay, if we want, we can put them that way. Okay, so now what we are finding is C, so we can make C the subject of the formula. Okay, I hope that is not a big deal to us. So what we can do here, we can just introduce the additive inverse of B squared. So if we do that, we are going to have A squared minus B squared equal to C squared. Okay, so if we have that, we can start with C because we want to make C the subject. It's already the subject that we can just bring it on the other side. And so we are going to have C squared equal to A squared minus B squared. Okay, A being the hypotenuse, B being the adjacent. So now that we have this setup, we can substitute. So on C we'll put x because there's x here. So we're going to have x squared equal to, where there's A, we can just substitute with 5. So we'll put 5 here, squared, minus, where there's B, we'll put 4. Okay, so it's going to be 4 squared, and then we'll have x squared equal to, what is 5 times 5? Okay, so 5 squared is basically 5 times 5, and this will give us 5, which is 25, minus, what is 4 squared? This will give us what? 16. Okay, so x squared will equal to, here we'll have 25 minus 16. What is 25 minus 16? So if we subtract here, we're going to find that here we'll get 9. Okay, we'll get 9 there. So we're not trying to find the value of x, as in we're not trying to find x squared here. We're trying to find the value of x. Remember, we're not finding x squared. If we were finding x squared, we would have stopped here. But we are trying to, we're actually finding the value of what? Of x. So here we're going to introduce the square root. The square root will be introduced here. So we're going to introduce the square root, and this will get rid of these two here, and the 9 here will find the value. So our answer will be x equal to 3. Because what is the square root of 9? The square root of 9 is what? 3. So the value of x here, okay, the value of x there will be 3. Okay, so that's how you go about solving this kind of equation, provided you have two sides that have been given and one side that is missing. You can easily find the answer like we did. Okay, let's go to the second example. Okay, I hope you have copied this. If you haven't, you have understood everything that I've explained. Okay, so let's look at another question. Okay, let's look at another question. Okay, so another question can be in form of this. Let's try to look at something like this. Let's say this time around, diagram has been drawn like this. Okay, so because they can draw it in any direction. Okay, and then here we have our theta. Okay, or our angle there. Then we have this part there. Okay, and then we're given these sides. We're given these sides to be, let's say, I'm given this side to be 4 millimeters, and then this side you're given as maybe 5 millimeters. Okay, you'll be given this one as 5 millimeters. Okay, then we're trying to find this one, A millimeters. Okay, we're trying to find what A is. Okay, so we've been given this side, and this side. So the first question we need to ask ourselves is, which sides are actually given in this question, and which sides are missing, or which side is missing? Okay, so understand that this is basically the hypotenuse when you look at it. Okay, because the hypotenuse is connected to the adjacent. The adjacent is the one that is actually as well connected to the what? To the angle. So we have the adjacent and the hypotenuse are the ones that are connected to the what? To the angle. So meaning this is the hypotenuse and this is the adjacent, and the upper part there, that is the opposite. Now our formula basically is a squared equal to b squared plus c squared. Okay, so if you're finding the longer sides, you're basically adding these two shorter sides. Okay, that's what you're trying to do here. Okay, so now we need to identify which one is our A, which one is our B, which one is our C. So our A has actually been given in terms of A, so it's A in millimeters. It will remain the way it is as A squared equal to, what is B? So B in this case, it's basically the adjacent. Okay, we can, if you want, we can even, so this is A, we can give this one as B, and even this one is C. So it doesn't really matter much if we are dealing with addition of small sides. Okay, it doesn't really matter like all that. If you want, instead of writing in terms of letters like the way they are, you can be writing them in terms of their names. And by this I mean, instead of writing them this way, so that you can avoid the confusion, you can just say hypotenuse squared will equal to adjacent, okay, squared plus opposite, okay, squared. This way you can also use that way. So you can use that, or you can use the one in terms of A and B as well as C. Okay, so if we have this, we'll continue with hypotenuse squared will equal to, what is the adjacent? The adjacent is 5 millimeters. Let me just grab these ones off. So the adjacent is basically 5 millimeters. So we use 5 squared plus, we have 4 here as the opposite. So 4 squared. So the hypotenuse squared will be equal to, what is 5 squared? It's basically 25, not so. So we'll get 25 here, plus, what is 4 squared? We'll get 16. Okay, we'll get 16. Then hypotenuse squared will be equal to, what is 25 plus 16? We can easily add 6 plus 5 will give us 11. So we have 1 remainder 1. 1 plus 2, that is basically 3 plus 1. We'll get 4, so that's 41. Okay, so we have the hypotenuse squared equals to 41. Now, because we are not finding The hypotenuse squared, we're trying to find the hypotenuse. We will introduce the square root. Even here we can introduce the square root. So the hypotenuse will be equal to, we'll try and find the square root of 41. Okay, so you can pause the video and try and see if you can easily just find the square root of 41. So I'm doing it right now. So the square root of 41, basically, it's 6.4. Okay, 6.40. So this will give us 6.40. Okay, so the value of A. So you don't have to leave it like that. This was given in terms of A. You can say therefore, okay, you can say therefore A will equal to 6.40 millimeters. Okay, and this should be obvious. Okay, this should be obvious in the sense that because this is the longer distance, it should be longer than this one, it should be longer than that one. There is literally no way you can find this distance to be something like 3 millimeters. Then logically speaking, it will not make sense. Okay, if we are calling this side to be longer than these two other sides, then what should make sense should be this side should be longer than these two other sides. That way, we'll be sure that the answer that we have found is a correct answer. Okay, so logically speaking, or logically looking at things, they should make sense. This should be shorter than this should be shorter, and this one should be shorter as compared to this longer distance. So that's how we go about solving these questions. Okay, that's how you go about solving these questions. Thank you very much for watching. Subscribe if you haven't for more, so that when I post a video you can easily see it and learn one or two things. Thank you very much.